I want to talk today about four updates in terms of water optimization for corn. And those four, I can get it to move here. There we go. Include, can advanced irrigation systems help save water for corn? Can biochar help save water? Can corn genetics help mitigate water stress? And last, do wetting agents help soil hold more water? I'm going to talk about some recent research that we've done to try to answer or begin answering some of these questions. So the first question, can we apply less irrigation and maintain yield with advanced irrigation systems? I'm not going to spend a lot of time on these. I've talked about these several times, and I think many of you are familiar with them. But just understand that there are lots of options when it comes to sprinklers or sprinkler packages that we might install on pivots. Most are probably familiar with this type of sprinkler all the way here on the left, called a mid-elevation sprinkler or MISA. This is what we have on almost all of the pivots in Utah. Something like an IWAB or a rotator that sits about 5 or 6 feet off of the ground. In the last couple decades, there's been a lot of other technologies, and here's just some of them, kind of broad categories. There's different types of low elevation sprinklers, some called a Lisa or a Lipa. There's another one called a Lena that Nelson makes. And there's lots of variants of these low elevation sprinklers. Usually they get closer to the ground, just a couple of feet off the ground, and the spacing becomes tighter, every 30 inches apart or every 60 inches instead of wider spacing that we see with most pivots. So what that means is these often become more expensive, right? Because we have more sprinklers, more parts. And then last, a more recent technology is drip irrigation for pivots, or mobile drip irrigation. This is the most expensive option, but gets the water right on the surface of the soil. So potentially provides some advantages of keeping water in the soil versus having it lost with evaporation or wind drift. So the past several years, we've conducted lots of different studies on these systems to see how well they perform. And really we wanted to see if we can use less water and still maintain crop yields if we improve efficiency with some of these new sprinkler technologies. So you can see that map there of where we have tested different systems for corn in different parts of the state. We've got a lot of information on these, and I want to try to cover that, but do it quickly. Just to give you an idea, we have 18 different scenarios where we've compared a full irrigation to a reduction. That's usually 20 to 30% less water applied with these different technologies. So first, I want to take you to Alberta. We conducted this work with Alberta Valley Ag, with Merrill West, who spoke earlier. In 2018 and 19, we looked at corn. And in the first year, there's a lot here, so please don't get lost in all of the bars and the letters. I just want to show you quickly where we saw differences. So in 2018, just look at these red circles at the bottom. So in 2018, we had one case where we applied less water. So we applied 30% less water with mobile drip irrigation, and we saw the same yield as the mid-elevation sprinklers at the full rate of irrigation. So a success. This system maintained yield with 30% less water. That was great. We look at it the next year, and surprise, we find a little bit different results. So the next year, we had two cases. One where we had a low elevation spray application with 20% less water, and again, mobile drip irrigation with 15% less water. We saw that it maintained yield. But in these other cases, we had some LIPA with reductions and Lisa on a different part of the pivot, and LIPA over here, and we saw reductions in yield when we put on less water. Okay, now I want to move to a different site. So one thing that we noticed in this research is that every span of the pivot, of almost every pivot, performs a little bit differently. And so it's really challenging to pinpoint how these systems compare. We tried to start breaking up spans a little bit to look at different parts of the span and if that influenced it, but it was just a challenge to do with center pivots. And so we started moving some of our research to linears. And linears are much more uniform in performance across the whole system. And so we were hoping to get a better control and to really get a better assessment of how these systems perform. So in 2019, we actually had 5 systems. We included this low elevation Nelson application, and we looked at several different rates for each of these systems and compared silage yield. 2019, we had a wet spring, if you remember, and we really saw very little difference. These systems all performed about the same, and there was no impact of the rate. The rates didn't act differently for each of these systems. So what that means is that all of those reductions could help maintain, or well, what it actually means is that there was a reduction in yield for all of these systems when we put on less water, and none of them could maintain yield with less water. And that's what we saw over here. So across all of those systems, as we put on less water, we saw less yield. Now in 2020, much more normal year, we didn't have the super wet spring. And again, there's a lot here, so please don't get lost, but just focus on these red circles on the bottom. So we had one case here with a Lena system, and one case here with the Lisa system, where we put on 25% less water and we maintained yield. So another 2 cases where we saw the same yield with less water. Okay, this same study we also have at Vernal. We just established that in Vernal last year. And what we saw at Vernal was similar. We only saw one case right here with the LIPA. We put on 25% less water and we maintained yield at the same level as if we were using a mid-elevation sprinkler. Okay, so I've shared a lot. I've shared 18 different cases here and just want to summarize quickly. So we had actually 5. I've got my number wrong there, I apologize. We had 5 cases where we saw we put on less water and we maintained our crop yield. But it didn't happen at the same site year after year. The results were really variable. And I showed you that at Alberta and at Logan. In one year we saw that one system did better, and the next year it didn't necessarily do better again. So we saw variable responses. So our numbers are wrong here, but this would be about 30. So about 30% of the cases we saw that we could reduce irrigation rates and still maintain yield with these advanced systems. So the point is that they're not going to save water in every field and in every year. We really have to be careful about where we might place these systems and realize that they may provide benefits in some, but not all scenarios. Okay, question 2. Can biochar help save water? What is biochar? It's a fancy way of saying charcoal. Biochar is produced with kind of a careful burning process called pyrolysis, and they take that byproduct, it's like a charcoal, and it's really popular for use as a soil amendment. And so we wanted to see if we used it as a soil amendment, could it help save or store water in the soil? So to do this, we conducted trials at 2 different spots. Again, we were working with Alberta Valley Ag on this research, and we applied 10 tons of biochar per acre in two different fields. And one of the fields had different rates of biochar. And I'm not going to show you all of the data, but I just quickly wanted to show you that in one of these fields, we saw in the first year really no difference in corn silage yield. Same thing in the second year. This is when we had reduced irrigation. When we had full irrigation, results were variable. 1 year, biochar increased yield. The second year, it decreased yield. And so the point I want to make here is really we had another field where we also looked at this, and the consistent summary was that biochar had no impact on yield or on the quality of the corn silage. So really no benefit that we saw in the first couple of years after application. Now on the question of water, I want to show you some results from soil moisture sensors. So we put sensors out in these fields and we looked at the water. And what you need to know about these charts is that the lower the number is, the lower this tension is, it means that there's more available water. So in this scenario here, this black and the red line means that there was more available water than the green and the yellow line. And so just really quickly want to point out up here in this red circle, you can see that when we put on biochar, 5 or 15 tons of biochar in this field, we had more water. And again, that happened some in the next year in that same field. If we look at the other field where we had different rates of irrigation, full irrigation and reduced irrigation, the results weren't quite as clear. You could see that sometimes so this red line here, this red dashed line would be the biochar. And you can see that sometimes it had more water, but the yellow line, the dashed line, when you compare that to the green, it had about the same amount of water for most of the season. So the summary of this was that sometimes we had more moisture in the soil where we applied biochar, but it didn't happen consistently and it didn't happen all season. And that additional moisture provided no benefits to crop yield or crop quality. So really found very little impacts of biochar. Okay, third here, can corn genetics help mitigate water stress? So drought tolerance in corn can come in a variety of ways. It can be bred into corn hybrids or it can be genetically modified. And for our trials, what we've been looking at is a genetically modified hybrid. So we've taken 2 hybrids that are very, very similar, except that one of them has an insertion of a drought guard gene, which is supposed to help it be more tolerant to water stress. And so we've got three scenarios where we've compared these 2 hybrids. In Logan, we've done that for 2 years, and we've done it for 1 year in Vernal. And the results so far have been highly consistent. We've seen really no advantages to the drought tolerant corn yet. It produces the same yield as the conventional over lots of irrigation rates. And when we water stress the corn, we don't really see any advantages yet of having drought tolerant genetics. So question 4 is, do wetting agents help save water? And there's lots of products out there. This is a product that it's actually manufactured here in Utah. And we received reports from several farmers that they were using it and seeing benefits from using it. And so we wanted to put it to the test. And so we've only have 2 scenarios where we've tested this. It's called AquaDrive. You apply it usually once or twice during the early parts of the corn growing season. In our case, we were only able to apply it once because it became really difficult to apply it later because we had differential irrigation treatments. And so in the 2 cases where we've tested it, we really have not seen any benefits yet. Again, so in 2019, we had equal yields with and without this AquaDrive. In 2020, when we applied it, we actually saw a small reduction in yield. Not sure why that was. I don't know if more water was stored in the soil and didn't make it into the plant. But really kind of preliminary work, we're hoping to repeat this at more sites to really get a handle on what kind of impacts it has. Is it economic? Does it work? Does it help save water when we're water stressed? So in summary here, can the advanced irrigation systems help save water? Yes. Our numbers here were wrong here again. Probably about 30% of the time, or about a third of the cases, we saw that we could apply less water and still maintain the yield. So we know they work, but just not in every field and every year. So we've got to be careful about where we place them. Can biochar help save water? Sometimes we see more moisture in the soil, but really no yield advantages that we can measure. Can corn genetics help? Haven't seen anything yet. We're hoping that we see more as we continue that research. And the same story for the wet agents. Really have no evidence yet that they're working. I want to thank a lot of partners who have helped make this research possible, and turn time to questions if we have time.